All right, we're going to look at making carbon-carbon bonds and cleaving carbon-carbon bonds. So at this point in time, we only know one way to do this. So far, we'll talk about others, but right now we only know one way to make carbon-carbon bonds. And we only know one series of reactions that will cleave carbon-carbon bonds. So let's talk about bond formation. The only way we know how is to start with a terminal alkyne, deprotonate it with a strong base like sodium amide to make an acetylide ion. That's a very good nucleophile that we can add to either a methyl halide or a primary halide, and it will do an SN2 to form a brand new carbon-carbon bond. Here's our new carbon-carbon bond that we're making right here. All right, so how do we use this tactic when we're trying to do a multi-step synthesis? So let's say we're starting here with this alkyl halide, and this is our target. All right, one of the things that you want to ask yourself first, and I'll dive deeper into this in another video, is did I change the carbon skeleton? Did I add or take away two carbons? And if I just look at it, I know the cyclohexane is the same. So I'm just going to kind of number here. I got one carbon outside of cyclohexane right there. And now I have three carbons. So according to this, I added two carbons. The only way I know how to do that is with an acetylide ion. So these two carbons here had to have come from an acetylide ion, right? And then this is my alkyl halide already. So let's come up with some reactions that will get us here. So here's my carbons 2 and 3. I'm going to deprotonate using sodium amide. And then I'm going to throw in the alkyl halide. So notice here, there's carbon 1, 2, and 3. You don't always have to show the mechanism. I'm just showing it so that you can see how bonds are forming. So I'm going to connect carbon 2 to carbon 1. And now I have three carbons there. 1, 2, 3. Now I've added my carbons. Am I done? No, because if I look at the end result here, that's an alkane. How do I go from an alkyne to an alkane? Well, that's a full reduction. I'm going to do a catalytic hydrogenation. Hydrogen and palladium, platinum, or nickel. And that will reduce the triple bond to an alkane. All right, notice how all of these reactions we have talked about in the past, all of them actually came from this unit that we just did. So I'm not even like bridging particular units. Now, what if the target has less carbons? Again, we only know one way to do this. That's oxidative cleavage, otherwise known as ozonolysis. So let's say our reaction looks like this here. Okay, if I number my carbons here, I got 1, 2, and three, and then I have one and two. I'll deal with carbon three in a second, but just kind of notice here my target has one less carbon. The only way I can do that is through an oxidative cleavage reaction using ozone. And since it's an aldehyde, I'm going to use zinc and water. Now, the other product to this, that single carbon there, is carbon dioxide. That's where carbon number three is. Now, alternatively, what if my target was a carboxylic acid? Again, if I numbered these things here, one, two, and three, this is carbons one and two. So how do I get a carboxylic acid out of this? Well, I still do ozonolysis because that's going to cleave the double bond. And then I use like an oxidizing agent as a second step, like peroxide, or alternatively, a reaction that will do the same thing is KMnO4 in acid. But we still get carbon dioxide as the other. That's where the third carbon is going. We could do the same thing with alkynes. We just learned this in this unit. If I take a terminal alkyne, react it with ozone and water, it'll make a carboxylic acid and carbon dioxide. Again, we're cleaving that those pi bonds. That's why it's called oxidative cleavage because we're using oxygen, an oxidizing agent. And the cleavage comes from the fact that we're breaking those bonds. All right, so those are a couple more tactics. In a little bit, or in the next video, I'm going to talk about how we can kind of work backwards to help us develop a much longer synthesis.